What's happening, guys? Welcome to the live stream. In this video, we're going to be going through a bunch of Python stuff, but specifically, we're going to be handling object-oriented programming and specifically classes, class inheritance. We'll also do a little bit on how we can define attributes and methods as well. So specifically, what are we going to be covering? Well, we are going to be going through how to cover classes and specifically how to build custom classes if you need to. And these classes come really in handy, particularly when you're doing some really hardcore deep learning stuff. So I've been doing a lot with the TensorFlow functional API. And what I've actually noticed is that in order to build really specific models or really slightly more advanced models, you're gonna wanna have a handle on classes. We'll also take a look at how we can deal with attributes and how we can attach methods to our classes. And then one of my favorite topics is class inheritance. So this is how we can build superclasses or subclasses from existing classes. And again, this is a common theme that you'll actually pick up when you start to use specific deep learning models like PyTorch or TensorFlow as well. So on that note, let's actually get to it. Okay, so let's go on ahead and we are going to start writing some code. So as per usual, what we're going to be doing is we're going to open up a Jupyter notebook that we've previously used. So I'm going to step into, what are we stepping into? Our command prompt. So I'm going to open up command prompt. And then I'm going to go to where my Jupyter notebook is. So this Jupyter notebook could pretty much be wherever, but we need to obviously go to that specific location to be able to open it up. So let's go do that. So I'm going to type in or go to our directory. So let's actually take a look at where that is first up. So I'm just going to bring it up over here. And so my stuff is inside of YouTube and then Python Basics. So we need to go to that location. So first up, what we need to do is go to our D drive. And then everything is inside of a folder called YouTube. And again, this could be in a different location based on where you're doing it. So that's perfectly fine. Just go to where your existing Jupyter notebook is and open it up. So we're going to go to our locations. I'm going to go to CD and then YouTube and then go into Python Basics because that's where we've been doing all of our Python for data science work. So let's go there. So CD Python Basics. And then we're going to kick Jupyter off. So again, how do we start Jupyter? We write Jupyter notebooks from our command prompt. What have I written there? Jupyter notebook. My bad. Jupyter notebook, not Jupyter notebooks. Okay, then I can minimize that and then we're going to bring it over here. So remember when we're working with our Jupyter notebooks, we've got the extension IPyMB. So we can open this up. And this is all the stuff that we've covered in our previous tutorials already. So we've gone through a bunch of stuff. So data types, lists, dictionaries, loops, conditions, functions. So we'll actually cover functions a little bit in here, but specifically methods, which are attached to our classes. So as per usual, we're going to start this off by creating a new section because we want to keep our things nice and structured. So we are going to create a new section. So I'm going to so remember to convert a cell into a markdown cell. So right now it's active. So you can see it there, it's green. Let's actually add some additional cells below so I can get this a little bit more centered. So I'm going to hit B, get a little bit more centered in the screen. And then right now it's active. So you can see that it's green. So how do we get out of this? We hit escape on our keyboard and then we want to convert it from a code cell to a markdown cell. So we're going to hit M and that is a markdown cell. Now this section is going to be called classes, because class is now in session. All right, so that's classes. Now, the class that we're going to create is we're first up going to create, and in continuing with our sort of space theme, we're going to create a class for a person. Now, we've already encountered classes a couple of times. So specifically when we were going through, what do we use classes for already? Well, a string is a data type, but I'm trying to think if we've actually encountered any classes. We might not have yet. Okay, we're going to create a class. So the class that we're going to be creating, or let's actually talk about what classes are first off. So classes are objects with defined properties and methods. Now, properties could be an attribute. So for example, a string had different methods attached to it and it had different attributes. So we're going to create a reproducible class, and this is like almost, think of it like a boilerplate for an object. So again, if you think of your classes as boilerplates for objects, right? And the nice thing about classes is that you can inject different properties into them. So say, for example, you're going to be using this for deep learning. One example is you might be creating a new custom layer for a specific deep learning model. What you might want to do is inject a specific number of layers or ensure that it has a specific type of activation functions. Classes are perfect for this because you have a shell or a boilerplate or a template which you can just plug in a bunch of values and have it set up the way you want. So what's a really good example of a class? Well, a great example, which we'll also build upon when we go to use inheritance, is a person. So think about what a person is, right? Really, we're a template, and all that's been injected into us is different types of DNA to be able to have a unique individual. But really, in our fundamental, or in its fundamental sense, we could be formed as a class. So let's actually create a class for a person. So what we're going to do is first up write class, and this is the statement that we need to pass through to specify the fact that we're creating a class. And then we're going to call it person, and then close it with parentheses and hit colon. And I'm just going to add in a few spaces. So again, as per Python syntax, in order to write anything under our class, we need to hit tab and indent it. So in this case, that indenting looks a little bit weird, so that it's now indented. So what have we written so far? So pretty lightweight at the moment. I've written class and then person, and you can see here that I've written it in capital. So that, again, this is just a preference. I like writing it in caps so I know what is actually a class. And then I've gone and written, what have we gone? We've put in parentheses and then a colon. So then what we can do is define a couple of things. Now, the first thing that you need to define whenever you're defining a class is a method or a function called init. So if we type in def underscore init underscore, and then parentheses and then colon. This is the method that runs as soon as you create a class. So as soon as we start using our template, when we first run it, the init method is going to run. Now you're probably thinking, hey Nick, this looks really, really similar to a function, right? So we covered functions already. Why are you calling this a method? The methods that we're defining here, or the function that I'm actually defining here, is a specific function which is attached to a class. That's why we call it a method. Now, classes are typically combined of two key things. You're going to have methods attached to them, and these are like functions that are attached to a specific class. And then they'll also have attributes or properties. So these are values that are attached to a specific class. Now, I'll show you how to get these out and how to use methods and how to get properties or values. But let's actually go on a little bit further. Now, when we are defining our class, the first thing that we need to do is pass through the variable self. This is basically telling us that we are going to pass through this instance of this class to this init function. Now, self is a little bit of a weird concept, but you got to keep in mind that when you're creating a class, you're creating a new instance of an object. So you want some way to refer to this particular object. And that's where the self keyword comes in. So when we use self, we're basically saying, hey, we are using the current methods for this instance of this class in this particular case. All right, so we've written def and then underscore init and then underscore, and then inside of parentheses, we've passed through our first argument, which in this particular case is going to be self. Then we want to pass through a couple of different parameters to our person, because remember, a person, or in this particular case, our person class, is like a template. So what are some unique characteristics for people? Well, we're going to pass through name. We're also going to pass through their age. And we're also going to pass through their favorite color. We'll just call it color in this case. So right now, this is pretty much a function, but it's a specific type of function, which is a method. And it's a specific method, which is attached to a class called init. And remember init, so it's short for initialize or initialization, initialize. It's going to run as soon as you go and create your new instance of your class. Cool. All right. So now what we need to do is we need to take these parameters that we've gone and defined here, so name, age, and color, and we need to assign it to our class, because right now these are just arguments that we're going to be passing through to our init function. So how do we set these up? Well, what we're going to do is we're going to assign them as attributes. So I'm going to create a new comment and say we are going to create some attributes for our person class. And the way to create an attribute is to specify self and then whatever that you want that name of that attribute to be. So in this case, we'll specify self.name and then we'll set it equal to the argument that we're getting from our init method. So we're going to set it equal to name and then we're going to create another attribute. So self.age and we're going to set that equal to age. And then we're going to create a last one, self.color. And we're going to set that equal to color. Right, so that is, if we did nothing else, that is a class now initialized, or that is a class now defined, not initialized. So if I go and run that cell, you can see that it's gone and run. Now, if I wanted to go and create an instance of this class, because remember, our class is like our boilerplate or our template. How do we actually go and create an actual person now? So we can go and say new person. So we're going to create a variable, and we are going to assign it, so equals our person class. So we're going to type in person, and then we need to pass through a couple of key arguments. And these are the arguments that the init function is expecting. So we don't need to pass through anything for self because our class is aware of itself. So we just need to pass through our name, our age, and our color. So in this case, let's go and do, I don't know, Elon. So Elon Musk, pass through our age, and we're going to say, I don't know how old he is. Let's say, let's keep it on the low side so I don't make him feel bad. We'll say 38, I don't know. And then his favorite color is blue. Right, so that is our new person now created. Now remember, our person is like a template. So what we can actually do with this template is we can actually go and extract these attributes. So remember, name, age, and color. So if I go and type in new person dot name, that is me accessing an attribute. Let's add some commentary. So accessing a class attribute. And you can see there that I'm actually accessing that person's name. So new underscore person dot name is giving me the name for that particular person, right? Now we can also access our age and we can also access our color just by changing the value after dot. Pretty cool, right? Now, the beauty of this is that it is repeatable, right? So if we wanted to go and add additional attributes, or if we wanted to go and add additional parameters, we could definitely do that as well. In this case, we've created a really simple one. So now what are we going to do? So that is our baseline method. So we've gone and defined our init function. And again, this is required when you go and create a class. So you need to have an init function in order to set up your variables. The next thing that we might want to do is, let's say, for example, calculate their year of birth, right? And again, we're going to do a really simple calculation. So what we can do is we can actually create custom methods inside of our class. So we can go back into our person class. And now what I'm going to do is create another method. So let's add a comment, and we're going to create a method to calculate their date of birth. So let's actually say date of birth method. And we are going to, again, we're going to define a function. So def. And then this time we don't need to specify underscore init. This is a built-in function for classes. We don't need to do it for our other methods. So what are we going to do? We're going to call it year of birth. And then we just need to pass through self so that this function or this method here has access to these attributes here, because we're going to need this age value, right? And then finish off our function with a colon. And then what we want to do is we want to return the year of birth. So we're going to specify return. And then we're going to keep it pretty simple and not fully parameterized in this particular case. So we're going to return, what are we doing? So 2021 minus self.age. Right? So let's actually take a look at what we've written here. So we've gone and defined a new method. And remember, it's a method because it's inside of a class. And our new method is called year underscore of underscore birth. And then to that, we're going to be passing through our current instance of our class. Remember, this allows us to access our attributes from within different methods. And then we've gone and specified that this function is going to be really simple. We're just going to return 2021 minus the person's age. And remember, this age is an attribute that we set up originally. So if we go and hit Shift Enter now, that is our person value, or that is our person class now updated. So what can we do now? Now we can actually go and calculate their year of birth. And remember, so we haven't actually gone and passed through any additional arguments to this, right? So if we go and run this method now, we should get our year of birth back. So if we go and run it on Elon again, so I'm just going to recreate it. So hit Shift Enter. And then for our new underscore person, we can now go and run our method that we just went and created. So I'm going to type in new. Let's actually create a comment. So we are going to run a method. So if I type new underscore person dot, and then this is the difference between using or accessing an attribute versus actually running a method. So when we run a method, we have to close it inside a parenthesis. So we're going to pass through year of birth and then add parentheses. And then if I hit Shift Enter, we are now getting our year of birth. So again, this is actually doing something now. So we're not just accessing an attribute, we're actually performing a calculation on some sort of value. So again, this could be repeatable. Another great application of this is say you were doing something with layers, like neural network layers. Actually, what's a better one? Say you wanted to consistently create a pandas class, right? Or create a specific data set for your model. You might actually set up your data set as a class and actually have specific attributes and specific methods attached to that. So say, for example, you knew that you consistently needed to bring in your data set from some random source. You then needed to go and pre-process it, but not always. You then wanted to go and push it out somewhere, right? You would actually set up this class as, say, for example, class and then data set. Inside of your initialization function, you might choose to set your attributes, and then you might also choose to go and bring in your data from wherever it might be. You might then choose to have another method, which is, say, for example, export dataset or import dataset. So you could actually structure this so you've got a repeatable set of steps that you can then go and run. Now, so what have we gone and done there? So we've gone and defined a class, and this allows us to work with object-oriented programming inside of Python. We've gone through how we can use the init method to set up our initial set of values there. And we've also gone and defined our initial method. Now we can also define different methods. So say, for example, we wanted to pass values to our method, we can do that as well. So what are we going to do this one? Say, for example, rather than just calculating year of birth, say, for example, we wanted to project how old they're going to be. Let's actually create a method for this. So we're going to add in a comment, so projected age. And we're, again, going to define a method, so def, and then I'm going to type in projected age. So this is going to be the name of our method. And remember, we're going to be able to access it similar to this. This time, however, we're again going to pass through self, but we're also going to take in a value for our projected age. So we are going to pass through a keyword argument. And remember, there's a difference between arguments and keyword arguments, or positional arguments and keyword arguments. Positional arguments order matters, and they need to go before your keyword arguments. Keyword arguments have a predefined value, and they can go in any order as long as they're after positional arguments. So we are going to say, I don't know, let's add in a new argument, and we're going to set it equal to years and 5. So this is basically going to be the default. So if we type in project underscore age, this is going to take the person's age and add on 5, right? So we're going to create a new keyword argument called years and set the default equals to 5. And then what we're going to do is we are going to return self.age plus years. And so this gives us the ability to pass through additional values. And again, pass through parameters to our specific class. So if we go and run this now, we need a colon there. Let's actually take a look at that error. So basically we've got a syntax error, and it's saying invalid syntax, and it's on line 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got an error on this line, and it's pointing towards the end, and that is because we don't have a colon there. And if we shift enter, all good, no issues. Now let's go and create our class again, but this time we're going to use our method that we are passing a value to. So in this case, our default is going to be 5, but we can also pass through our own value if we want to do or project a different age range. So if we go and hit shift enter on our new class, so we've got our color, we've got our year of birth. Now let's actually run our project age method. So if I type in new underscore person dot project age, you can see that it's projecting our person's age as 43. And this is basically saying that in 5 years, Elon is going to be 43. Now we can pass through our own values. So say, for example, we said years equals 10. you can see that we're now passing through a new keyword value or new keyword argument to go and project our age out a little bit further. And again, we can add in a comment because it's good practice, guys. Comment your code. So we're going to say run a method with a keyword argument. Pretty cool, right? And so again, this is really, really important because you'll often encounter classes with methods and with attributes. And it's important to know how to access an attribute versus how to actually go on ahead and run a method. And this makes it super easy. Once you've got a good understanding of this, the world's really your oyster when it comes to Python. So getting this down pat makes your life a whole lot easier. So that in a nutshell is how to create a class. So let's take a look at what we've done. So we went and created a class, and our class, in order to define it, we just need to write class and then the name of the class. We then went and defined a initialization method. So we wrote def underscore init and then passed through self because we want to refer to our current instance of our class or this particular instance of our template. Passed through a bunch of positional arguments and we went and set those as attributes. We then went and defined a method, and remember, a method is a function attached to a class. And this particular method is called year of birth. And again, we're passing through our self because we want to be able to reference this current instance of the class. And that one's just returning a person's age, so 2021 minus the person's age from our class. And remember, we can access our attributes from within our class as well. So remember, self.age is going to be able to get this value up here. And then we also created a new method called project underscore age. And this one is taking through a keyword argument. And remember, we need to pass through self. That's our first positional argument that we need to be passing through. And then we're going and specifying a keyword argument, which in this case is years. And so this gives us the ability to do this and be able to pass through additional values to our methods when we're actually going ahead and creating our classes. To create a new class, we need to define that particular class, or in this case, we need to specify that we're creating an instance of that class, so person, and then we pass through the positional arguments that are required inside of the initialization function. So in this case, we're passing through name, Elon, age, 38, favorite color, blue. Then we can access our class attributes. So again, we can type in the instance of that person or the instance of that class. Remember, the instance of the class that we just went and created is called new underscore person. So to get our attribute, we need to pass through the attribute value. And remember, it's separated by a dot. So new person dot, and then you can, the world's yours, like grab whatever you want. So in this case, we're grabbing color, but we could also easily grab the name, grab the age. So that's the way to access your attributes. Then we can also access all of the methods. So we can type in the instance of that class, so new underscore person, and then we can run that specific method. So again, separated by a dot. And then we call the method, so year underscore of underscore birth, and then pass through a set of parentheses to get our person's year of birth. Then we can also specify our methods and pass through keyword arguments to those. All right, I think we're doing pretty well. So let's take a quick break and let's have a look to see who's talking, who's here. What's happening, PowerCube? Yeah, it's super hard not to look at the chat while I'm coding. Thanks so much, Jack. Thanks for tuning in. Thanks, Express. This is a really good question. So we just got a question. So why use self.age over here instead of just using age? Keep in mind that this variable is going to be available within our initialization function. We want this age value to be available across the board. So by setting it through as an attribute, we're establishing good practices, and we're also ensuring that we are referring to the variable that we've defined as part of our class. So using self.age is going to mean that we're grabbing the specific variable that is attached to that class. What's happening, guys? Comment your code. Yes, always. No, PowerCube, never is not the right answer. Always comment your code. It's good practice. Alrighty, we are going to keep powering through. So we've now gone and defined our class. I'm not going to go through it again because we've done it. The next thing that we are going to go on ahead and do is perform something called inheritance. So this is really, really important. So inheritance should probably be a separate section, but we'll include it still here. Say, for example, we want to extend our class, right? So in this particular case, our class is a person. But what happens if we had specific types of people that we wanted to go and define? Let's say we had a Formula One driver. They might have some additional attributes. Say, for example, they might have a specific license that they have. They might have specific cars that they've driven. In our particular case, what happens if we wanted to define a class for an astronaut? Well, we've already gone to all the hard work to actually go and define a person. So why can't we just take all the attributes and methods that are attached to a person and attach those to an astronaut, but then we just add some extra stuff to our astronaut to build it out? Doing this is actually known as inheritance. So basically, we can take an existing class and take all of the good stuff inside that class and just add in the extra things that we need. So this means that we don't have to go and redefine the entire class every single time. And when we go and update our base class, which in this case is our parent class, which is person, these are going to flow through to, eventually will flow through to our child class. So in this particular case, that's an important thing to note. So this is going to be a parent class. And what we're going to do is we're going to inherit, or our child class is going to inherit all of these attributes and values. So important thing to note. So parent is the person, or is the class passing down attributes and methods. And your, let's add another comment there. And your child class is the class inheriting the methods and attributes. So this is really, really useful when you have frameworks that you're using that you want to sort of base on. So if you actually go through to the this is where I actually use this week. If you actually go to the TensorFlow functional API documentation for deep learning, when you actually go and define custom layers or custom models, what you actually do is you use inheritance to access all of the attributes and the methods that are available to existing TensorFlow models and TensorFlow layers. So you might think, Nick, I'm probably never going to use this. Trust me now, you will definitely use this, or you'll at least see it at some point as you go through your data science journey. So understanding inheritance is super useful. So what we're going to do is we're going to step into our cell. We're going to give us a little bit more room to breathe. So I'm just going to hit Shift Enter. And actually, let's convert this cell to Markdown. So we've already got classes. Let's actually do inheritance. So I'm going to hit Escape out of this, hit M, and I'm going to get rid of these pound symbols. Just hit dash, dash, so we can have some dot points. And we don't need this in caps because that's aggressive. Inheritance. And this is going to be section 6. Cool. Alrighty, so now what are we going to do? So we're going to create our astronaut class. And our astronaut is going to be our parent class. Astronaut is going to be our child class. So this is going to equal astronaut. And our parent class is going to be person. So this means that we don't need to go and redefine all of these parameters, name, age, color. Our child class is going to be automatically able to inherit from that particular class. So again, we define it as per usual. So we're going to create a class. And we are going to call it astronaut. So class astronaut. But this time, what we're going to do is we're going to pass through our parent class, which in this case is person. And then we're going to hit colon. So that's the main difference. So now we're going to be inheriting from the person class, which is this class over here. Then we're going to create a new line. And again, as per usual, we're going to define our init function. Initialization function. So def underscore underscore init underscore underscore. And then this time we are going to again pass through self. But we're also going to pass through a couple of additional values. Now, key thing to note is that we still need to pass through the values that our parent class is expecting. So name, age, and color. So let's first define those. So name, age, color. But now what we can also do is we can also pass through some additional arguments. So we'll actually define, what's a good one? So how long the astronaut's mission is going to be. So their mission length, for example. So mission length. And we'll do it in months. And then close our init function. And then what we're going to do is we're first up going to set up our class so that it inherits from our person. So to do this, we actually use the super method. So super, and then dot init. And then we're going to pass through our name, our age, and our color. So what this is actually doing is this is actually telling our child class, in this particular case, our astronaut, to inherit all of the stuff from person so that we then have name, age, and color available as attributes. This is inheritance in a nutshell. So this, if you take nothing else away from this, this is what gives us inheritance. Super method. Just remember Superman. That's how I've got it in my memory path. If you haven't checked out that video, do check that out. But the visual cue that I've got to remember that is just remembering Superman doing random stuff. So super allows us to inherit from our parent classes. Now, the next thing that we're going to do is create another attribute. So we're going to save our mission length in months as an attribute. So self.mission length. And then we'll say months equal to this value here. Cool. So that is our astronaut class now defined. So what we can then do is create a new astronaut. So we'll say new astronaut. And again, to define our class or create our class, we're just going to type it out. And then we're going to pass through all of the positional arguments that we need, or as defined by init function. So we're going to pass through, I don't know, let's say I'm an astronaut. So Nick, my age, let's say 99. Let's say our color, I don't know, purple, and mission length in months. Let's say I'm going away for, I don't know, a while, 48 months, right? I'll just stream from space. What we can then do is access all of the existing attributes as well as methods. So if I type in new astronaut dot, you can see that I've actually got all of the same attributes. Let me bring that a little bit further down. I've actually got all of the attributes that were attached to my person class now attached to my astronaut. So remember, we didn't actually go and define the age attribute, or what were the other methods, or the project age or the year of birth methods. We actually just inherited those from our person class. This is inheritance in a nutshell. So this means that we don't need to go and redefine. So that's our age method. Bit of a shame in it. That's our age method. That's our name method. Oh, that's our name attribute. And then what else do we have? Color. So you can see that we can actually access all of these attributes from our parent class, which makes it a whole heap easier. We don't need to go and define all of these custom classes every single time. So again, I've used this a ton of times, and you'll probably use it when you do get to this, specifically for deep learning, when we're inheriting different components from layers or inheriting different components from other models. This makes your life a ton easier. Now, again, we could also create a specific method. So again, let's actually just go through. So we can use color. And so this is accessing, let's say, access parent like parent like attribute. And then we're going to specify our method. So new astronaut dot, and let's, what's their year of birth? That means I was technically born in 1922 based on my age being 99. Now we could also go and extend out our method. So let's go on ahead and do that. So we are going to add, what are we going to do? Let's actually calculate their age on return. So how old would I actually be on return? So we're going to create a new method called age, or def. Let's actually add our comment first. So method for calculating age on return. I'm going to specify a new method. So def age on return. And pass through self, and we are going to, again, we don't actually need to pass anything through because we already have our mission length in months and we already have our age. So what we are going to do is we are going to project our age, right? So this is the cool thing about this, is that we don't actually need to go and create a full new function to actually do this. We can actually use our existing project on age or project age method that we had from up here. So I can type in return self.project age. So this gives us the ability to access the methods from our parent class as well. Because remember, we've gone and used our super function or super function to be able to go and inherit from our parent class. So by typing in self.projectAge, I'm actually accessing this method over here from our parent class. Then what I can do is pass through, what do we need? So self.missionLength in, what did we call it? Mission length months. And then divided that by 12, because right now our project age method is expecting the number of years to be passed through. Actually, we need to specify this as years equals. So let's go on ahead and test that out. Let's make sure we've done that right. Project age, yes. Okay, cool. So let's actually test out that method now. So if we type in, let's create it again. Boom, boom. New astronaut dot age on return. Yep. So we've got an error there, and that's just me typing way too fast. So you can see it's on line 1, and it's saying syntax error unmatched parentheses. That's because we need one of these beforehand, and delete that one. And you can see that is projecting our age on return. So you can see there that we've returned 103.0. Now remember, right at the start, we said that we could do something called typecasting. So how might we actually convert this into an integer rather than a float? Well, we can go on ahead and wrap it. Let's wrap this. So we can wrap the value that we're passing through. So int. And if we go and run it again now, you can see that we're just returning 103. So that in a nutshell is inheritance. So we've gone through that reasonably quickly, but let's go on ahead and take a step back and take a look at what we did. So we went and created a child class. Remember, inheritance allows a child class to inherit a number of attributes as well as methods from a parent class. In this particular case, our parent class is our person and our child class is our astronaut. So basically our astronaut class is going to be inheriting our age attribute and a bunch of the methods that we define as part of our person class. Then to define a child class, we can type in class again, so as per usual, but then we're going to pass through the parent class that we want to inherit stuff from. And again, this just makes it easier and reproducible. It also means that you have less code. So a big thing about writing code is that you want to write stuff that's going to be as modular and as reproducible as possible. So this is really where classes come in handy. What was I saying? So I passed through the person to our child class, and then we've gone and again defined our initialization function over here. We've then gone and defined our super method or our super function, which allows us to inherit from our parent class, and we need to pass through the arguments that we want to use in that particular case. And then we're going and passing through creating a new attribute, in this case mission underscore length underscore months, and we're going and extending out one of our functions. So we're actually accessing one of the methods from our parent class and doing a little bit of, and we're actually using this or attaching that particular method to another method. So our age on return method is actually just using our project age method from our person class, which is up here. So again, that gives us the ability to not have to write this all over. And then when we're going and defining our child class, again, it's exactly the same. So when you actually go and initialize it, it's going to look no different to you actually just using the base class, apart from the fact that you need to pass through all of the new positional arguments that you would have had to inside of the parent class as well as the child class. So in this case, these classes or these arguments over here, these are actually arguments that are required for the parent class. Remember, this is our name, our age, and our color. And this is required by a person class. So name, age, and a color. But we've also tacked on the mission length in months up here as well. Then again, we can access the attributes and we can also access the methods. Again, comment your code, access the methods, and then run a method. And that in a nutshell is classes. So we've gone through a bunch of stuff. So we specifically went through how we can define a class. And remember, you need to use the class statement. And then you need to have an initialization method to be able to go and set up your attributes. You can then go and attach a number of methods. We also took a look at inheritance, and this basically makes our code more reproducible and more modular, so we can go and use it over and over and over again. So we could also go and create a new child class called, I don't know, Formula One driver or lawyer or accountant, and have specific attributes and specific methods that are attached to that particular child class. Cool. All right. That is it in a nutshell. Let's take a look at some comments. What's happening? Power Cube, you got me a bit of a shame, Init. Thanks so much for ZK Blen. Thanks, Shadow Slayer Hero. Hey, thanks for checking it out, Jose. My GPU is 72 degrees Celsius. Yes, ouch. Thanks so much, Cool Rock. Glad you enjoyed it. Any additional questions, guys? Shoot them through. It's just water today, no beer. Thanks so much for checking it out, Chen. Yeah, so the data science tutorials were definitely going to be going further into all of this stuff. So again, this is just basics so everyone can go up to speed. Question. So can we access the attributes of a method to another method if they are in the same class? Can we access the attributes? So you can access the attributes of... So you can actually go and use a method to go and set an attribute value if that's what you're talking. So yeah, so that would mean that you can actually do something as part of your method and then return it back and have it as a attribute inside of your class. So yeah, you could do that as well. Cool. All right. No, it doesn't look like we've got any additional questions. So maybe let's wrap it up. Move this out of the way. So again, thanks so much for tuning in, guys. Hopefully you enjoyed the video. If you did, be sure to give it a big thumbs up, hit subscribe and tick that bell. And again, let me know if there's anything else you'd like to see. Hopefully you've enjoyed this tutorial. Thanks again.